Okay, we're going to do this. You should have out the function operations and transformations, the video lesson, piecewise defined functions, problem 1. I'm going to walk you through this problem. We're going to start out with a piecewise function, and the first direction is to graph that function. The first part of the function is 3 times root x plus 3 minus 5, and that you see is in the domain of, in the area of x between -3 and 2. I'm going to mark that down. So that function is going to go from -3 to 2. We're going to start out by graphing this function using our parent functions. Our parent function for this one is root x, which looks like a function like that. The root x plus 3 will make that function shift to the right, to the left, 3 units. So that's our new function. The next transformation will be that that function will move down 5. So we'll go 3 and then 5 over. That's our function now. And then the 3 and the front of it will stretch that function out and make it a little steeper. And so that function will go like that. That endpoint, or that AB reference point, will be at -3 and -5. So we have a closed dot right there. And that's going to go somewhere up to here. That endpoint will be 2, that one right there. So let's go ahead and plug that into the function. 3 root 2 plus 3 minus 5 becomes 3 root 5 minus 5. That number is a little bit more than 1, a little bit less than 2. At 2 is going to be somewhere in here. That is a closed interval. And I'm going to mark that 3 root 5 minus 5 right there. And our function is a square root function, so it's going to kind of go like that. And that's our first part. That's our first piece of the piecewise function. The second one looks like a quadratic, and the parent function to this one is a quadratic. Start out with x squared. It's a quadratic function. Say x minus 2 squared. That quadratic function is going to shift this way 2 units. So it's a quadratic function, x squared plus 5. That function is going to go 2 that way and then 5 up. Same function. And the next transformation is we're going to put a negative in front of it. So that function will be facing down. The next transformation is we will have 1/2 in front of that. And then we'll make that function wider. So it's in the first quadrant, it's wide. Its vertex is at 2. Plus 5. Is at 2 plus 5. So I'm going to get the endpoint by putting in the 2, this 2 right here. The endpoint of that. So I'm going to write down the graph, the function -1/2. That x will be the 2. That's this 2. 2 minus 2 squared plus 5. And we can see that this is going to go to 0 times 1/2 is 0 plus 5. So that's going to be at 5. So 2, 5 is our other endpoint. and that point is going to be open. That will be open. And the graph going this direction is not part of the domain that we want. It just starts at 2, so it's going to go this way. It's going to be a little bit wider, as we saw from our parent functions and our transformations. So we just need the endpoint. That's 6. So we're going to plug that in, -1/2, and then 6 minus 2 squared plus 5. This becomes 4 squared times a -1/2 plus 5, and this becomes -16 for 2 plus 5, and we have -8 plus 5 is equal to -3. So that's going to be at 6, 1, 2, 3, 4, 5, 6, and then down to 3. That's a closed bracket, and our quadratic is going to go in that type of a line. Okay. So here's our graph. Keep in mind that hole right there is open. Let's try to make it. That is an open hole. Okay. This will be a closed endpoint. And then let's go through and answer the questions that are given. Question number 1. What is the domain of f of x? And then we can use our graph to find that domain. Our domain is from this point here, which is going to be the -3. It's going to go to this point here. This point is not part of the domain. And then to that point. So it is going to be from -3. Our domain will be from -3 to the 6th value here, and it is closed there. We could have written it as -3 to that point, which is 2. That would have been closed, union with that 2, and then to the 6, which is closed. These are the same thing, as it has to do with this problem. Number 2 is that we're going to find the roots of the function, and we can see that our roots will be here is 1, and here is another root. So we can estimate what those are just by looking at the graph. We can find out exactly what they are by solving each piece of this piecewise function, setting it equal to 0, and then solving for x. So let's do that. 3 root x plus 3 minus 5 is equal to 0. So this becomes 3 root x plus 3 is equal to plus 5. Root x plus 3 is equal to 5 divided by 3. And then we're going to get rid of the square root by squaring that, and then also squaring that side. So it becomes x plus 3 is equal to 25 over 9. And then we're going to move that 3 to the other side. 25 over 9 minus 3. And we're going to put those two numbers together. It's going to give us 25 minus 27 over 9. Gives us a -2 ninths. And that will be our first root. And that looks like it would have been right in here. Our drawing was a little bit off, so that's going to be actually going right through there. So we're pretty close from our drawing. And so that point right there is -2 ninths. Alright, so we need to find the other one, and that's going to be the other piece of the piecewise function. And use the other equation. We're still on number 2. This is -1/2 x minus 2 squared plus 5, and then we're going to set that equal to 0. So this becomes negative 1/2. X minus 2 squared is equal to negative 5. Multiply both sides. Negative 2 over 1. Negative 2 over 1, and this becomes x minus 2 squared plus 10. We're going to root each side. And then we're going to root that side as plus or minus 10, root 10. Plus or minus root 10. And then this is just the root x minus 2 is equal to plus or minus root 10. And x is equal to plus or minus root 10 plus 2. So we have two values. X is equal to root 10 plus 2, and x is equal to negative root 10 plus 2. So it has to be one of these two. This number looks like it's this part of the quadratic that we're not using. That's restricted according to the domain. So it looks like it's going to be this value right here. So our answers to question number 2 are x is equal to negative 2/9 and x is equal to root 10 plus 2. So we're going to move on to number 3. We're going to find the exact values. Find the exact values for f of 4, f of negative 2. So we're going to start with question 3, or we're going to continue with question 3. We're going to find f of 4. This is a function composition, can also be written as f of g, f of 4. You may have seen it in that form. We're going to work with it from here. The f of 4, according to our graph, is this value right here. It's somewhere up in here. We can just plug that into the function f of 4, the function. That would fall with the second piece of the piecewise function. So we'll write that in just to find the exact value. That x value is 4 minus 2 squared plus 5. And this becomes 2 squared, which is 4. So negative 4 over 2 plus 5, and this becomes 3. So the value of f of 4 is 3, and then we still have that f on the on the composition part of it, so it's f of 3, and that also falls in the second category. That is going to be somewhere in here. It looks like it's going to be a greater value than what we had on the first part of that. Let's go ahead and plug that in as well. So it becomes 3 minus 2 squared plus 5. And this becomes 1/2 plus 5, negative 1/2 plus 5, and so that becomes 4.5. That's an exact value. And that's the first part. Also, the second part of that would be the f of negative 2. So we're going to go to negative 2. That means that we're going to use the first part of the piecewise function, this one. Negative 2 is going to be a value somewhere in here, negative 2. So we're going to use that first part. And that is 3 root negative 2 plus 3 minus 5. And that becomes 3 1 minus 5, and that value